multiplying mixed numbers and reducing before solving. So we had a previous lesson on multiplying mixed numbers and then just multiplying across the tops, multiplying across the bottoms, and just simply getting your answer. But when you have large mixed numbers like this, the calculated work tends to get a little busy, a little complicated if you have large numbers involved. So I'm going to show you how to make life a little easier, and before you actually go ahead and multiply, how we can reduce within. So first let me change this mixed number to its improper fraction, and that's going to be 2 times 5 plus 2, and that's 12 over 5. That's 2 2/5 mixed number as an improper fraction. So now I'm going to multiply by 5 and 5/8, so that is actually 45 over 8. And as you can see, these fractions are kind of large. But again, if you want to just go ahead and multiply straight through, you're going to get that 45 times 12 is actually 540. If you don't believe me, you can go off to the side and do your math there, multiplying and doing your two partial products and all that fun stuff, and you'll see that you actually do get 540. And then at the bottom on the denominators, we could do 5 times 8, and we'll get 40. So we have this big improper fraction, 540 over 40, and some of you that are division experts can probably go ahead and reduce this right here and divide within, but those of you that are still a little rusty on your division, which I think most of us are at this point, you can go off to the side and do your division to change that to its mixed number. And we have a double-digit divisor here, so again, they do tend to get to be big numbers. 40 does go into 54. We have once, so we're going to subtract 40. I'll do the long division. We've got 14 left over. We're going to bring down that 0. Now we have 140. So I'm going to do 340 times 3 is 120. And I'm going to have 20 remaining. So my new numerator is 20, and my denominator is 40. The answer I have here is 13 and 20 over 40, which of course I know I have to reduce. And some of you are clever enough to see that you can just cancel out those zeros, and then you have 2/4, and you know 2/4 is 1/2. And then some of you may actually have to work that out by dividing over and over again. But we see here that our answer is 13.5. Okay, now let's see how we can make this problem a lot easier. There's a lot of work here involved in these large mixed numbers. So if I go ahead and I take the same improper fractions, which obviously you have to, 12 over 5 and 45 over 8, I want to recognize that I could possibly simplify within or reduce within the example here. And I could do that by looking at the opposite numerator and denominators of the two different fractions. So if I look ahead and at the two opposite numerator and denominators, I want to look to see if they have a common factor that I can divide them both by, almost as if these were fractions that I want to simplify. For example, I want to look at the 45 and the 5, and I want to think of it as if it was 45 over 5. Can I simplify that fraction or reduce that fraction by using a common factor? Well, indeed I can. I do recognize that I can simplify the 5 and the 45 with the common factor of 5. The 5 divided by 5 is 1. 45 divided by 5 is 9. Now I'm going to inspect the opposite numerator and denominators. Sometimes you can reduce them, sometimes you cannot. In this case, we can reduce them, so we can actually make our life even easier than before. So we recognize that we can divide both of these by 4. That would be their common factor. 8 divided by 4 is 2. 12 divided by 4 is 3. So now I've changed this example to be 3 over 1 times 9 over 2. That becomes a lot easier and a lot more comfortable to solve right there. So 3 times 9 is 27, and 1 times 2 is 2. That I can actually easily change that improper fraction to a mixed number, but then again, if you're still rusty and you still have to go off to the side and do that division, that's fine too. This is a smaller number. You're less likely going to make an error with these kind of numbers than you will with those numbers. So let's see, 2 goes into 2 once, and then 2 goes into 7 3 times, and I have 1 left over. So yes, we definitely got that 13.5, but we got it a lot easier. Let's take a look at another quick example. We have 4.5 times 2 and 5/9, and I want to change that 4.5 to a mixed number, to an improper fraction. Oh, sorry, I need my pen. And that's going to become 9/2, multiplied by 2 and 5/9, which then will become 23/9. Now again, if I was to just go ahead and multiply straightforward, I would get 207/18. Another improper fraction that can get kind of tricky if I'm not too good at division. But I do see if in the end, if I wind up doing that division, I'll get 11.5. Okay, and you know, again, to show how you would do that division, usually with the double-digit divisors, you go off to the side, you're going to have to do that long division, and you'll have to do all that work, and you know, you'll just kind of see how that comes along. Anyway, let's show how we can do this by reducing before solving. So I've got the 9/2 times the 23/9. Well, in this case, I see that I cannot reduce the 2 and the 23. They do not have a common factor that I can reduce these two numbers by. So I have to leave them alone. However, I do see that I can reduce the opposite numerator and denominators on this side, the 2 9s. And obviously, their common factor would be 9. So I'm going to divide them both by 9, and I'll get 1. So now this becomes 1/2 times 23/1. So much nicer to solve here. So I get 23/2. Again, a lot easier of a problem to want to solve. And again, if you're rusty on your division, it's no problem with going off to the side on your scrap paper and doing that work. 2 goes into 2 once, 2 goes into 3 once, and we've got 1 left over. And therefore, again, we get the 11.5 answer, but in a much easier way.